Hello Lamai. Today I'm going to discuss unit number 1 of your combined mathematics syllabus. Right, unit 1 number 1 of your combined mathematics syllabus. For especially this is for the students, we have covered, this is the part that we have covered up to now. So this is for the students, those who have missed this part, right? Actually the unit number 1 is from pure mathematics, right? Is from pure mathematics, and it is real numbers. This unit we are talking about actually this is some like introduction, okay? We are introducing some terms for you that are very important. So this lesson is very important actually, right? A very small lesson but important, right? Okay, let's start. First of all, we are going to talk about the natural number set. Now you know about counting numbers, what we are using to count. What are the numbers that we use to count? 1, 2, we are counting like 1, 2, 3, 4. That is the way we count. So we call them counting numbers also. We call them natural numbers. The term that you're going to learn is natural numbers, right? So these numbers that we use to count, we call them natural numbers. So what is the natural number set? Yes, we represent it using this n, right? N. We have to write it. So this is the way to represent the natural number set. So I can write it as 1, 2, 3, 4. These are the elements in the natural number set. 4, 5, 6, 7, 8, 9, 10, like that. Okay, so that is the first one, natural number set. Then how about 0? When we include 0 to this one, we write this as the whole number set. We call it the whole number set. Yeah, I will write it here. Natural numbers. Natural numbers. So how to represent natural numbers? Using this n. And how to write? So what are the elements in this set? 1, 2, 3, 4. These are the elements. 5, 6, 7, 8. The numbers that we use to count. Clear? Then we are going to talk about the whole number set. So you have heard about the whole numbers, right? Whole number set. Okay, that is represented using the W. So what is this whole number set? Yes, now natural numbers means 1, 2, 3, 4, the numbers that we use to count. Okay, whole numbers means with this number set, right? This number set including 0. My number sticker, my natural number set including 0. So how to write the whole number set? 0, 1, 2, 3, 4, 5, right? So these are the elements in the whole number set. Clear? Right. So like this we are going to learn some numbers, different kind of numbers here, right? And the next number set is the integer set. I hope that you are familiar with all these terms, right? Definitely you are familiar with all these terms. Sometimes you may have doubts. Clear? And also you don't know these symbols. We actually use these symbols hereafter. We use these symbols. Clear? The symbols natural number set, then integer set. We are learning. When you are getting questions, you are getting x is an element of this. They will give like this. So definitely you should know that x is a natural number. What are natural numbers? That means x can be 1, 2, 3, 4, 5, those things. Not 0, not negative numbers, not decimals. Clear? So these notations are very important, right? Right. Then the integer set. Integer set we represent using z. Okay, this is the way to write integer set. What are integers? Yes. Now you have 0, plus 1, plus 2, plus 3, plus 4, like this. Right? And this side you have the negative numbers. Minus 1, minus 2, minus 3, like this. We have the negative numbers. Clear? So, the positive, these ones including the negative numbers 0 and the positive numbers, actually the whole number things, right, not the decimal values. Still we are not talking about the decimal numbers yet, we are just talking about this whole number things. So 0, 1, 2, 3, 4, those ones, and minus 1, minus 2, minus 3, minus 4, minus 5, those are what we call the integers. Clear? So now can you understand that whole number set is a subset of this one. The may set එකේ මෙයා ඉන්නව නෙමෙයි. Clear? And natural number is a subset of this one. This is a subset of this one. Clear? Okay. So this is what we call the integer set. So integers we can divide into two parts. I mean integers, there are two kind of integers. What are they? Positive integers, right? Positive integers and negative integers. There are two types of integers. Positive integers and negative integers. What are positive integers? Plus 1, plus 2, plus 3. So those are the positive integers, right? So positive integers set පුතේ we are representing using the integers represent කරන්නේ මේ set ගන්නේ. හරිද? Positive integers represent කරන්නේ අපි. Now how to represent positive integers? We are representing it like this. Z plus. Clear? The negative integers Z minus, and we can write the elements in the set. Right, so what are the elements in the set? Plus 1, plus 2, plus 3, plus 4. So we can see that this positive integer set is equivalent to the natural number set. My positive integer set එක කියන්නේ natural number set එකම තමයි. Can you understand? They are equivalent, same thing. Then negative integers means yes, minus 4, minus 3, minus 2, minus 1, these things. Okay, so you can write it like this: minus 1, minus 2, minus 3, minus 4, so on, the negative numbers. Okay, they are what we call the negative integers. So we are writing a minus sign here. Now if you need to include 0 to this set, or not 0 include that means positive integers including 0. You can write a 0 here. Positive integers including 0, and you can add a 0 to this. Okay, so we are representing. So these notations actually you should know definitely, right? So when you, I told you that they will give x is an element of z plus. So you should know that this is a positive integer. X is an element of z minus. Then this is a negative integer. You just know, right? So these terms are very important, right? So we talked about the natural numbers 1, 2, 3, 4. Those ones counting numbers. Whole number set means the same set including 0, and the integer set means the negative whole number things, and 0 and this 0th included. How is the integers can 0th included? 1, 2, 3, 4. Those ones can be divided into two: positive integers and negative integers. The positive integers these positive numbers, negative integers means these negative things. Okay, right. Now yes, you can note down the things. I will give you like 1 minute. Right. Now next Lamai, we are going to talk about the rational number set. Natural numbers, whole numbers, integers, and now we are going to talk about the rational numbers. Right, rational numbers. What are rational numbers? Yes, so they are. I am going to teach you something very important also. Right, now listen well. Right, so the rational numbers are defined like this. Right. Now I talked about 3 sets. I didn't talk about this decimals or fractions. No. So they are also numbers. Clear? Right. Now we are going to talk about the rational numbers. This rational number set we represent using Q. Q. Right? This is the notation. Rational numbers. Then this is the notation for rational numbers. Then what are these rational numbers? Lamai. Right? So rational number set is defined like this, Pute. I will write it here and then we will discuss. Right? Rational number is a number which is in the format P over Q. It is a number which is in the format P over Q, where P and Q are elements of integer set. You know the notations now, right? P and Q are elements of the integer set, right? And P is not equal to 0. Q is not equal to 0. Denominator is not equal to 0. Then P and Q integers Q what are integers? Negative values -1, -2, -3, 0, +1, +2, +3, +4 So P and Q can be integers. This one is an integer, this one is an integer, but there is a restriction. Q cannot be 0, but P can be 0. P to 0 and Q to 0 and can you understand? Right, that is the rule, right? And also there is another thing that P and Q do not have common factors, right? So this is the way where P and Q don't have common factors. So this is the way to define rational numbers, right? A number that can be written as P over Q, such that P and Q are elements of integers where Q is not equal to 0, but Q is not equal to 0. Then Q is 0 when the integers when on Q to 0 when when on integer P to 0 when P can be 0 also. Clear? So this kind of one is a rational number. Right? Any number that we can express as a fraction. Any number that we can express as a fraction is what we call a rational number. The denominator cannot be equal to 0. And P and Q both should be integers. For example, 2 over 3 is a rational number. 2 is an integer, 3 is an integer, therefore 2 over 3 is a rational number. 0.5 is a rational number, we can write this as half. 1 is an integer, 2 is an integer, therefore 1 over 2 is a rational number, 0.5 means a rational number. Clear? So what do you think about 2? Is this a rational number? Is it in the format P over Q? Yes, it is also in the format P over Q. See, we can write it as 2 over 1. 2 is an integer, 1 is an integer. So 2 over 1 is a rational number, means 2 is a rational number. Then how about minus 2? Minus 2 is also a rational number because we can write this as minus 2 over 1. And also put the numerator, denominator, one integer, negative. Clear? Right, so minus 2 is also a rational number. Minus 3 is also a rational number. Plus 100 is also a rational number. Clear? How about 0? Is it a rational number? 0. 0, how can you write 0? 0 we can write as 0 over 1. 0 divided by 1 is 0. Clear? Still, numerator 0 උනට කමක් නැහැ නේ. මේගොල්ලෝ කියන්නේ denominator එක 0 වෙන්න බෑ කියලානේ. ఇది న్యూమరేటర్ 0 ఉన్నట్టు అవలక్ నే therefore numerator can be 0, denominator cannot be equal to 0 thing hari so this is also a rational number, 0 is also a rational number. Can you understand? Okay, so any number that we can represent as a fraction is called a rational number. Right, now I'm going to discuss why this denominator cannot be equal to 0. I mean denominator is 0 when very clear to me, then discuss karan hadane. This is very important. Okay, right, this is very important, listen me. So now we talked about the rational numbers. Right, I will discuss why this cannot be equal to 0. Denominator cannot be equal to 0. Right. Now what do you think about the value of 1 over 0? Right, now usually when I ask this question in the class from the first time learners, like the beginners, they give us the answers like some of them tell 0, some of them tell 1, right, like that they give different answers, right. So we will discuss whether it can be 0, whether it can be 1, right. අපි ඒක මුලින්ම clear කරගමු. Now if you are a first time learner, then definitely you will have the same doubt. That's why, right? Okay, අපි බලමු මෙයා 0 වෙන්න පුළුවන්ද කියලා. හරි. Usually මේ බලන්න පුතේ. Now 6 divided by 2. Now this is just a discussion. I'm going to show that denominator what will happen when the denominator is 0, because here there is a restriction. අපි මේ කතා කරපු rational numbers වල denominator 0 වෙන්න බෑ කියලා කියනවා. So why is that? That's what I'm going to discuss. Right? Okay. Now 6 divided by 2 means what? 3. We can write 6 as 2 times 3. Okay, right. What else? 10 divided by 5. 10 divided by 5, 2. I can write 10 as 2 times 5. If some students say that 1 over 0 equals to 0, then කවුරු හරි ළමයි කියනවලු 1 over 0 equals to 0 කියලා. එහෙනම් I think according to this one, he can write that 1 equals to 0 times 0 නේ. Is it correct? 1 equals to 0 times 0? Can't happen, no? Clear? 0 times 0 is 0, right? So this is something wrong. The answer is wrong. 0 වෙන්න බැහැනේ. හරි කවුරු හරි තුත් 1 වෙන්න පුළුවන්ද කියලා? Is it possible? So you, according to this one, according to this pattern, I just gave this as a pattern, you already know these things. So 1 equals to, then 1 can be written as 1 times 0. And I think 1 times 0 is 0, no, it is not 1. 1 times 1 is 1. Clear? That is again, so this is also wrong. 1 over 0 is also wrong. 1 over 0 is 1 is also wrong. Then what is the answer? Yes, what is the answer? Okay, now I hope you can understand that these two answers are not possible. 1 or 0, 1 hari 0 hari venna bෑ neda answer. That is impossible. Then මොකද වෙන්නේ අපි බලමු. Right. Okay. So I'm going to discuss about this like this. I'm going to discuss about 1 over 0.1. What is 1 over 0.1? Yes, what is 1 over, I will write it here. What is 1 over 0.1? This is not the proof of this one, right? මේ මම කියලා දෙන්නේ ඒක ආට මම මේක idea එක තමයි මේ කියලා දෙන්න හදන්නේ. Can you understand? Right. So 1 over 0.1, right, is equal to, now this is 1 over 0.1. 0.1 means 1 over 10. So you know 1 divided by 1 over 10 means 10. 1 divided by 1 over 10, 1 divided by 1 over 10 means 1 divided by, this is 1 over 10, means 1 multiplied by 10 over 1. Clear? So you should have the idea actually, right? So I hope you can understand. So if there is any student those who have doubts, that's why I told that. So 1 over 0.1 is equal to 10. Like that, what is 1 over 0.01? Yes, this is 1 over 100. 1 over 100. Therefore, 1 over 0.01 should be what? 100. 1 over 0.001 is 1000. So on we can go, and I will just go for this 0, 0, 0, 0, 1. What will be the answer? 1. Here we have 3 zeros, here 3 zeros, right? You can get the pattern. This will be the answer. 100,000 will be the answer. 1 over 0.00001, you will get 100,000 as the answer. Clear? Then we denominator මොකක්ද වෙන්නේ ළමයි? What happens to this denominator? What do you mean by 0.1? Right? මම මෙහෙම number line එකක් ඇඳලා ඔක පෙන්නන්න. හරිද? This is a number line. You imagine that this is a number line. එතකොට මෙතන 0 තියෙනවා. Number line එකේ here you have 0 and here you have 1. හරිද? එතකොට 0.1 කියන්නේ කාටද? Now I'm talking about the denominator. I'm talking about these denominators. Right? What is 0.1? How to mark 0.1? Yes, now here 1 I am dividing by 0.1. Here 1 I have divided by 0.01. Here I have divided 1 by 0.001. Clear like that? So I'm discussing about this denominator only. I'm asking how to mark 0.1. We have to divide this into 10 parts. Make 10 parts to divide karana and then I'm going to take the first part, and that is what we call, here we can find 0.1. Clear? We have 10 parts to divide karana. This gap you have to divide into 10 parts. Yeah. Then we have to select the first part, that is 0.1. Clear? Then how to get 0.01? How to get 0.01? Yes. This part I'm going to divide into another 10 parts. May part එක මම තව 10 parts වලට divide කරලා ඒකෙන් first part එක ගන්නවා. That is what we call 0.01. Is it clear? Right. Then what is 0.001? This small part, මෙන්න මේ චූටි part එක තියෙනවනේ. එයාව divide කරන්න ඕනේ to another 10 parts and take one part. Then we can find here 0.001. So can you see these denominators get closer to 0? එන්න මේ මම ලියලා තියෙන denominators හැමෝම කාටද ලං වෙන්නේ? 0 ට ලං වෙනවනේ. මෙහෙට යන්නේ නැහැ. එන්න ලං වෙනවා විතරයි. මේ පැත්ත පනින්නේ නැහැ. තේරුණාද? ඒතුර negative numbers වෙනවා. These are not negative numbers. These are positive numbers. These are positive things. Clear? එයා මේ පැත්තට skip කරන්න විදියක් නැහැ. හරි. එතකොට එන්න 0 ට ලං වෙනවා. 0 වෙනව නෙමෙයි 0 ට ගොඩාක් ලං වෙනවා. They are getting very closer to 0. හරි. එතකොට ඔයගොල්ලන්ට තේරෙනවද now the denominators here this value of the denominator that get closer to 0, right? The value of the denominator get closer to 0, right? We say the denominator tends to 0, right? The denominator tends to 0. What happens to these values? Overall value of the fraction. I mean 1 over 0.1 ke 1 over 0.01 ke මේ overall value එකට මොකද වෙන්නේ ළමයි? Yes? means that is getting larger නේ. එන්නේ ලොකු වෙනවා මේ බලන්න. denominator එක පොඩි වෙන්න කියන්නේ denominator එක 0 ට ලං වෙන පුතේ this value is getting larger. Right? So what happens when denominator tends to 0 then? Exactly 0. We say that the value tends to a very huge value, right? We call it infinity. Okay, we call it infinity, a very large number, right? And we represent it using this symbol. This is the symbol that we use, infinity. You may have heard about infinity. So this is what it means. So we say 1 over, if you have x here, so we have a lesson called limits. So there we can understand this very well. So when this x tends to 0, this overall fraction tends to what? Infinity. This overall fraction tends to infinity. So there is no exact value. මෙහෙම හරියටම කියන්න පුළුවන් value එකක් නැහැ. ඒක real number එකක් නෙමෙයි. ඒ කියන්නේ real number එකක් කියලා හරියට මෙන්න මෙයා කියලා අපිට කියන්න value එකක් නෙමෙයි ඒක. Can you understand? This is a very huge value. That's all what we can tell about infinity. Right? So that is undefined. Dividing by 0 in mathematics is undefined. Clear? So we say dividing by 0 is undefined. Right? ඒ කියන්නේ අපිට කිසිම number එකක් 0 කින් divide කරන්න බෑ. තේරුණාද? That is undefined. those values tends to infinity value. Infinity like it will be a huge value. Like when denominator tends to 0, when the denominator tends to 0, the value tends to infinity. Overall value, I mean the fraction infinity. Fraction overall value because infinity to lang tends to infinity. Make a loop okay. This is the symbol of infinity. Can you understand? So that's why, right, you have to write dividing by 0 is undefined in mathematics. Clear? Right. So when denominator tends to 0, 1 over 0 value tends to infinity. Clear? This is getting larger. Right. When the denominator get closer to 0, the value get closer to infinity. That is the idea, right? So you can have a rough note. This is not, I mean, you can write there dividing by 0 is undefined, right? Dividing by 0 is undefined. Clear? The answer is not 0. Okay, right? You can have a rough note there. So there we can have examples also. 2 over 3 minus 2 over 5, 2 minus 3, 0, all these things. Right? We have there are many rational numbers. Many rational numbers can, right? So these are some examples actually, right? So here I explained why divided by 0 is undefined, because when the fraction is 0 ganne pa kiyana reason එක තමයි මම explain කරේ. Clear? That is very important fact. Okay, very important fact. Okay, so you can have a note, your note. Okay. Right now we are going to talk about it. Now we talked about rational numbers. Now we are going to talk about the irrational numbers. Right? Irrational numbers. What are irrational numbers? Rational, irrational. So I think you can understand that is the opposite of that. So we know that we represent it using the Q dash. Can you Q complement? Can you remember that? Set A, the things that does not belong to set A, we represent using A complement, the same thing. Right? So here rational numbers means Q. Irrational numbers we represent using Q complement. Clear? Right. So here, what do you mean by irrational numbers then? Now, rational numbers means any number that we can represent as a fraction using an integer in the numerator and the denominator, where denominator cannot be equal to 0. Then, what is an irrational number? Yeah. So, the numbers that cannot be represented. How do the fraction එකක් විදියට ලියන්න බැරි numbers තියෙනවා. There are numbers that we can't write as a fraction. So such kind of a numbers, we call them irrational numbers. Okay. For example, these non-recurring decimals. Let me have the 1.2131625. You don't have any pattern. No, not recurring. So these kind of ones we can't write as a fraction. How does recurring right? For example, like 1.232323. This one we can write as a fraction. I will show you. Right? These are rational numbers. But if we don't have any pattern here, so these kind of ones we call them irrational numbers. They can't actually write as a fraction. It is we can't write it as a fraction. So that's why we call them irrational numbers, right? So, for example, root 2, root 3, root 5, right? Then you have learned about 5, right? So these ones, they are irrational numbers. So 5 22 over 7 all of us, but still that is actually to ease your calculations or calculations. This is almost a closer value but not the exact value of 5. Clear? So 5 is also some decimal non-recurring decimals, so value with non-recurring decimals, right? So that is what we call the irrational numbers. What are the type of numbers that we learned up to now? We talked about the natural number set. 1, 2, 3, 4, these things, right? Then we learned about the whole number set. This number set including 0. This number set including 0. Right? Then we learned about integers. Right? I thought main number set we have the negative numbers also. We have negative things also. Negative integers also included. Same thing including negative integers. Then what is rational number set? What we call rational numbers? Any number that can be represented as a fraction. So I told you that these ones also we can represent in the same way. So my rational number set integers included, 0th included, everything in integer set is here, there, right? Or any number that can be written in the form P over Q, where P and Q are elements of integers and Q is not equal to 0. How many Q is? This is then irrational කට්ටිය කියලා කියන්නේ කවුද? මේක නැති කට්ටියට. හරිද? එතකොට පුතේ දැන් මේ numbers ටික ඔක්කොම මෙයා right මෙයා මේ ඔක්කොම මෙන්න මේ හැමෝම මේක included. හරිද? මේ set එකේ ඉන්නේ මේ කියන්නේ Q dash එකේ ඉන්නේ මෙයාගේ නැති කට්ටියක්. The numbers which are not in the rational number set. So these two number sets, including all these numbers, we call it the real number set. Right? Real number set. Real number set means all these numbers that you learned now. All these numbers that you learned is what we call real number set. Okay? So you can write down real numbers. You can write down real numbers. And write what are real numbers? All the rational and irrational numbers. All the rational and irrational numbers. ඒ කියන්නේ මම මෙච්චර දවසකට දන්න හැම ජාතියම number එකක්ම මේ අපි real numbers කියලා තමයි කියන්නේ. All the rational and irrational numbers. Clear? Right. All rational and irrational numbers we call real numbers, and the notation for real numbers set is this R. Okay? Right. එතකොට දැන් මෙහෙමයි හරියද? දැන් real නේ. එතකොට real නැති දෙයක්වත් තියෙන්න ඕනනේ. real numbers. There should be something not real, so that we call this real. There should be something not real. So we have some numbers called imaginary numbers, right? There are numbers called imaginary numbers. The numbers that does not belong to the real number set, we call them imaginary numbers. For example, for these imaginary numbers, square root of -1. This is the imaginary number. Can you find the square root of -1? Yes. This is the imaginary number. Clear? So these ones also, you are learning a separate lesson called complex numbers, where you are learning about these imaginary things, right? Okay. So I'm not going to include that part here in the first unit. Okay. However, we are learning up to real numbers, right? So there are some numbers outside there. That means which are not real. We call them imaginary numbers. For example, square root of -1. You just keep that in mind. You will learn that later. Okay, so what am I then represent Venn diagram making? I can represent all these stuff using a Venn diagram. How? This is the natural number set. Natural number set. 1, 2, 3, 4, those things. Then you have the whole number set, including 0. You have the whole number set. I write it W. Okay. Right. So this set is a whole number set. It includes all the natural numbers and 0 also. It has a set including these negative integers also. That is what we call the integer set. The negative integers. In this one, this includes the negative integers, positive integers, and 0 all. How do you negative integers because positive integers and 0 are in these circles, in these two circles. And this integer set is a subset of the rational number set, rational number set. Rational numbers. The fractions and decimals, those ones are the rational numbers here, right? So this is the rational number set. This one, all are integers of the rational number set. It has to teach me. The last one that I'm going to draw, I'm drawing is, this is the real number set. Include real number set. What you have inside this are the irrational numbers. Clear? There you have the irrational numbers. Okay. So this is the, this way we can represent this as using a Venn diagram. Clear? Okay. You can draw this one also. Okay, Lamai. So now we're going to talk about this decimals. So we have two types of decimal numbers because we talked about the recurring decimals and non-recurring decimals, and I told you that non-recurring decimals are irrationals, right? So we're going to talk about that. So decimals, we have two types of decimals: finite decimals, right? Finite decimals. These are definitely rational numbers. May finite decimals are common. We can write them as fractions, right? These are rational. Okay, and there is the other type, infinite decimals. That means the decimal values they do not stop. Now, for example, this one just 0.5, 0.3 like this, 0.31. Clear? Then 1.232. That's all. It stops there, right? But infinite decimals means it does not end. Two types there are. First type is recurring decimals, and the next one is non-recurring decimals. Recurring decimals you may have done 4 levels also, right? Recurring decimals and non-recurring decimals. So recurring decimals means, right? See example 0.232323. This repeats. These are recurring decimals. Non-recurring decimals means 1.2135. You don't have any pattern, just it's not recurring. Clear? I thought recurring decimals. These are rationals. They are rational numbers, right? They are rational numbers, and these ones are irrational numbers. Right? These ones are irrational numbers. Okay. Now I'm going to show you that how we can write this on the monkey one rational scale. Now I will give some examples for you. 0.5, or else let's go for another one. 3.8. I want to show that this is a rational number. How? I can write this as 38 over 10. Okay, right? 38 over 10. So you can see here it is an integer, and this is also integer. So this is actually 19 over 5, right? So integer in the numerator, integer in the denominator, then definitely this is a rational number. So 3.8 is a rational number. Can you understand? Another one, 10.35. Decimal what is it? 1035. Divide by 100. Okay, so we can write as a fraction. Make a simplify and then we can write this as a fraction. So definitely what? This is a rational number. Can you understand? So Pute, finite decimals we can write as a fraction always. So fraction means we can write in the format P over Q, where P is an integer, Q is an integer, and P and Q do not have common factors. By writing, simplifying this further. So these are rational numbers. Then how about this recurring decimals? Now recurring decimals these ones you can understand. Finite decimals can. Now I am going to tell about this recurring decimals. Are the recurring decimals? 0.232323 I am going to show that we can write this as a fraction. Fraction right. I will take this as x. 0.23233 part x I will take it as x. It pass say I will multiply this by 100. I will multiply this by 100. You see what happens when I multiply this by 100. 100x is equal to 23.232323. Maybe the one 23 line now. Infinitely 23 line now. Clear? The decimal point 2 times when it skips this way now when you multiply by 100. Now I am going to subtract, right? I am going to subtract. I will take this as number 1, I will take this as number 2 and I am going to subtract these two now. I mean subtract කරනවා. Then subtract කරනවා මොකද වෙන්නේ? Yes, 100x minus x means what? 99x is equal to, what happens when you subtract these two? 23.23232323 again. When you subtract 0.232323, are 232323 many parts දෙක තියෙනවනේ. Decimal point එකේ. Those things will become 0 now. මේ subtraction එක ලියලා බලන්න. පොඩි කාලේ වගේ ලියලා බලන්න. 23.232323 like this we repeats. 0.2323 here. I'm going to subtract this. Can you understand? We're getting 2, 3 here and all this becomes 0. So, मैं हमें कम 0 वेला है ना. I हम 0 वेन नॉन नहीं सकते हैं. मम इतना 100 के multiply करे. इतना recurring part टेके ना decimal point के पास से. If I multiply by 10, it will skip here. इतो तो subtract करने वाला संट. Clear? इतो को तो आठ 10 नहीं. मैं तो ना 2.3232 हमें. तो को तो subtract करना अभी तक इतना हमारे है. That is difficult to subtract. हम subtract करने नहीं अरे subtract को make part टेक माइंग में लाए ना जिधर subtract करने तमाम अभी multiply कर लगा ना this line. Clear? So I multiplied by 100 so that this skips 2 decimal places and this is 23.23232323. When I subtract 99x is equal to 23. Clear? I can divide both sides of this equation by 99 now. I will divide both sides of this equation by 99. So I will get x equals 23 over 99. Clear? What is x? What is x? X kilo gatte kavada. This one here 0.232323. This recurring decimal is equal to 23 over 99. So can you see Pute, we have arrived to an answer which you have two integers in the numerator and denominator both. So this is a rational number. That means this is rational. Right. So this is the way to prove. This is the way to show these kind of ones. Okay, you write down this example and we'll do some 2 or 3 questions, right? Right, let me, so this recurring thing, so we are representing like this, we are putting a dot here, the meaning is that this value repeats 0.777777. If you have 2 digits that repeats, 0. For example, 0.62 repeats, 626262, we can put 2 dots in 6262. If 3 numbers repeats like 1, 2, 3 repeats 1, 2, 3, 1, 2, 3 like that, we put dots to these 2 end ones, which means this whole part repeats. Clear? So like that there are different notations. I'm going to show that this is the rational number and this is the rational number. Right. This one. This one, okay? 123.1. We will get this one. So how to write this one? 1.23.123 like that. Or else if you have 0 here, so we have to write like this, 0.123 dot. The meaning is that 0.123123 like that it repeats, right? So how to do? I will take this as x equals to 0.7777 like this. Okay. I will multiply this by what? 10. So you can pause the video and you can do this, right? And then check my answer. I will do this now. Right? So I will multiply this by 10. 10 can multiply karama. This keeps once. 10x is equal to what? 7.7777. Clear? I will take this as equation number 1 and take this as equation number 2. Then subtract the two equations. 10x minus 6, 9x. 10x minus 6, 9x equals to, right, see, 7.7777 minus 0.7777. This 7777 parts will be subtracted by this part. So zeros. 7 minus 0, 7. So x equals to what? 7 over 9. X can X can. So 0.7 dot 0.777 we can represent using 7 over 9. We can write it as 7 over 9. Is it clear? Right? How about this one? Here also I will take this as x. X equals to 1, 2, 3, 1, 2, 3, 1, 2, 3 like this. Right? So I have to multiply, 0 point. Right? Okay, I have to multiply this by 1000. Recurring part multiply. So I will multiply this by 1000. So 1000x is equal to 123.123.123 like this. So on it goes. Right, this is equation number 1. This is equation number 2. Subtract them. 2 minus 1. Clear? So it is 1000x minus 6. 999x is equal to 123. So x equals to what? 123 over 999. Like this we can find. So we can show that. Now what you have to do, understand is rational numbers, these recurring decimals are also rational numbers. We can write them as a rational, but still the ones which are not recurring, they are irrational numbers, right? They are irrational numbers, okay. Right. Right. Now we are going to talk about the intervals, right? So a new topic, intervals, right? This is very nice one, right? Something you already know, but here also I'm going to teach you some special notation, actually, special notation, right? Now you have a set x such that you have some values x. we have an element x such that x is greater than a less than b. Greater than a less than b. So I can represent this using a number line like this. You have a number line. You have a here. You have b here. Where are the values which are greater than x but less than b? X ට වඩා වැඩි b ට වඩා අඩු කට්ටිය කොහෙද ඉන්නේ? Where? Yes, that is in between this region. This is the way you mark, no? But these ones we draw circles because we are not getting those two values. ඒ දෙන්නව ගන්නෙ නැහැනේ. එතකොට ඒ දෙන්නගේ in between කට්ටිය විතරනේ. So we have to draw circles. If we get those ones, we have to draw a dot. Clear? හරි. එතකොට මේ set එක මට ලියන්න පුළුවන් මෙන්න මෙහෙම new notation. See, I'm used to writing this as a comma b. So a comma b means the set of x such that x is greater than a less than b. We can represent it using a number line like this. Clear? Right. The next one is පුතේ this one. දැන් මෙන්න මෙයා මම අලුතින් introduce කරන්න මේගොල්ලන් වනේ මේ notations ටිකනේ. Right. X is an element such that x is greater than or equal to a less than or equal to b. X is greater than or equal to b. X can be a also, but greater than a also, and less than b or equal to b, like that. And so how can I represent it? Using a number line. Same way a and b on the number line. Then you have to draw dots there because we have to include these two. Then may they not include කරන්න ඕනනේ. So you have to draw dots and you have to, the values in between this region we get. Now notation එක මොකක්ද දන්නවද? මෙන්න මේ කට්ටිය represent තව විදියක්. Other than writing like this, මෙන්න මේ විදිහට ලියනවට. ලියන්න ඔයගොල්ලෝ පුරුදු වෙලා ඉන්නේ. This is the new method to write. Okay, this is represented like this. A comma b using square brackets. Okay, what do you mean by this square brackets? Yeah, you have to include a and b. මේ ay by include කරන්න කියන එක. Clear? මෙතනදී අපි ay by ගන්න එපා කියන එක තමයි they ask not to take this a and b. That is the idea of these brackets, right? So we call this an open interval and this is a closed interval. Open interval, closed interval. Clear? Right. So this is the way to represent the square bracket එකක් තියෙනවා කියලා කියන්නේ they ask you to take a also. A to b values including a and b. Just a to b values, right? Without a and b. Then how to represent this one? මෙයාව කොහොමද represent කරන්නේ? x a x is greater than b less than or equal to b. X is greater than a but less than or equal to b. එයාව කොහොමද represent කරන්නේ අපි? You have a here, you have b here, right? Including b නේ. එතකොට b include කරන්න ඕන ඔය. හැබැයි ඒව ගන්නෙ නැහැ. So this is the way to represent it using a number line. හරි. ඔතන ඕකම අපි කොහොමද how to write it as an interval? Yes. We are writing it as ab. අදන් ටීචර් මොකද්ද කිව්වේ මෙතනදී? ඒව include කරන්න නැත්තම් you have to draw a bracket like this. Open interval. Open වෙන්න ඕනේ side එක. ඒතර මේක closed. Right? We call it a square bracket. We have to put square bracket when the value can be equal to b. The last one now you can guess. I will write it directly. The last one is this. A comma b. What do you mean by this? What do you mean by this? X is an element such that x is a value, x is such that x is greater than or equal to a but less than b. We can represent like this. Okay, so here ලියන්න number line එකේ a b like this we can denote it. Can you understand? Okay, so these are the new notations that you learned. So these things you already know. You're familiar with the number line and write in this way, right? This is the new way that we can represent it very easily. A to b, a comma b, without a and b. This one, a to b, a comma b, including a and b square brackets. Clear? අතර මෙයාව open interval, open bracket, I parenthesis, and then a to b, a comma b, square bracket. Clear? Like that we can write. Hope you can understand this. You can note down. Okay, so you can pause the video and write the things. Now I'm going to introduce you the infinity, right? That means this, right? So I told you about infinity. Okay, very large number. I mean, we know the symbol now for infinity. So Pute, if you draw a number line, and if I shade the values from there here to here, I will shade, if I shade this whole thing, right? If I shade this whole thing, this represents this interval. I can write as minus infinity to plus infinity. We had to write an open interval there, right? Keep in your mind, අපි කොයිලාවකවත් infinity sign එක ගාව closed brackets එක මේ square brackets දාන්නේ නැහැ. Clear? Because we don't know the exactly what is this infinity. Infinity කියන value එක exactly කවුද කියලා දන්නේ නැහැ. මෙන්න මෙතන තමයි infinity ඉන්නේ. So what is here then? Clear? We can't mark like this. එහෙම mark කරන්න අපිට බෑ infinity කියන එක කියලා. Can you understand? So always you have to draw these kind of brackets near infinity. Infinity sign එක ගාව home brackets තමයි අපි දාන්නේ. So this is actually the real number set. This represents the real number set. Minus infinity to plus infinity. All the numbers means the real number set. Can you understand? Number line එකේ මේ ඉඳන් මෙහෙට වෙනකම් from this way, from minus infinity to plus infinity. Every value we represent using this way, and that represents the real numbers. මෙයාගේ represent the real number set එක. Clear? හරි. දැන් අපි તો මෙහෙම කරන දුන්න කියලාට. So you can note down this also. Minus infinity to plus infinity. That is the way to write. I will write x is an element of minus infinity to plus infinity. We can write like this. X is an element of minus infinity to plus infinity. Right? This is the way to write. Then this one. Right. Here you have a value a here, and you have a value b here. Then I will shade this region. I will shade this. And from here to here. And I will shade this circle. So how to write this one? කොහොමද මෙයාව inequality එකක් විදිහට ලියන්නේ දැන් මම what I have shaded. How to represent this shaded part? So we have some unknown elements here. I have in the regions that I have shaded. I will take them as x. So this x, the value of x is an element. X කියන එක නා මම shade කරලා තියෙන හැමෝම represent කරන්නේ. We have lot of numbers now. මම shade කරපු කට්ටියම represent කරන්න තමයි I'm using x. So x is an element of what? How to write? So always you have to start to write from the left hand side. Left hand side එකෙන් තමයි මේක start කරන්නේ. මෙහෙට තමයි යන්න ඕන. හරිද? එතකොට මෙහෙ ඉන්නේ කවුද? minus infinity. Open parenthesis. Minus infinity. Okay? To a. Without a open interval. ඒව include කරන්න බෑනේ circle එකක්නේ. You can't include A. We have to pick union. Can you remember union? What do you mean by union of two sets? Take all the elements of those two sets. Union B to plus infinity. Infinity side dekේ කොහොමද open into. This side should be closed. Why? We have to include B. So we can represent this like this. Very easy. Okay? Right. Now, another example. You have A, you have value B, you have value C here. Right? So I'm going to I will do like this. I will shade like this. Okay? Okay. How to represent this one? So I ask you to start from this side. X is an element from starting from here, including A to B without B, union C to plus infinity, C to plus infinity without C. Like this we can write. Okay, so these are the ways that we can represent. Now without writing the inequalities, we can use this method to write the to represent these regions, this shaded region on the number line. We can use this method, right? Okay, so that part is also over, right? Right, now lamai I will give two shaded regions and you have to write the intervals, right? Some examples let's do. Okay, you have to write down the shaded regions now. You have to write using intervals. About these shaded regions. Right? Then teacher got a harim kehta hai main liye na ogolanga rulers thiyena na you can draw double lines, okay? I would colors using blue then it is written. Right. So I want the parts that I have colored using blue. Okay, these ones I will give 1 minute time to do. Hurry up and write. Right, this is actually a video on so I will be revising the things. That's why. So you can pause the video and do. Okay. Right. Okay, so let's discuss about the answers for this, right? From here to here, minus infinity to a. Here this side we have the minus values, minus infinity. So minus infinity to a, then b to c, c to infinity. I have marked these ones also, so how to write? So we have to neglect c now here. But c wa ganna bෑනේ මෙතනදී. එතකොට එකපාරම යාව ලියන්න බෑ. Clear? So we have to break there. See, x is an element from minus infinity to a, minus infinity to a without a, union b to c without b and c both, without b and c both. Again, union c to plus infinity. Clear? Other moment in this c wa and here also I have neglected c. So you separately clear? So however you can connect it with a union, right? And this one, right? This one, minus infinity to a. X is an element from minus infinity to a without a, union again from a to b including b, a to b including b. Clear? How about this one? X is an element from a to b without a and b, union c to d including c without d. This must be our answers. Clear? So that is the way to write. Okay, so pause the video and do the corrections. The last part of the lesson, right? Last part of the lesson, we're going to talk about the surds. We're going to talk about surds. What do you mean by surds? Now you have done for O levels. What do you mean by surds? Any value, okay, a value which is inside a square root, represented using a square root. We can have some other integer here also, right? This must not get simplified to a whole number. Then square root for the end, then this is not a root. Why? This is not a surd then. Why? Because we can write this as 2 then. Clear? If it is a surd, it should not be, we should not be able to simplify this to a whole number. For example, 8. This is not a surd. Cubic root of 8, 2. Clear? This is not a surd. But if you have here 5, this is a surd. Clear? Yes, we have one represented using this way, a, n, right, which cannot be simplified to a whole number, which cannot be simplified to a whole number. Whole number eකට simplify වෙන්නේ නැහැ. Yeah, හරිද? එතකොට එහෙම කෙනෙක්ට තමයි අපි surd එකක් කියලා කියන්නේ. එතකොට මට කියන්න බලන්න මේ surds, for example root 2, root 3, root 5, those are surds. හරි. එතකොට අපිට පුළුවන් ද surds දෙකක් add කරලා, can we write like this? Is this correct? Is this correct? Yes. This is not correct. This is wrong. Clear? I will explain this one. Then මේ වගේ values ගන්නකො මෙයාලගේ values අපි දන්නවනේ. So root 4 plus root 4 can we write as root 8? That's completely wrong, right? Because root 4 plus root 4 means 2 plus 2, 4. Clear? එතකොට අපිට මෙහෙම add කරලා කියන්නේ when you add them, we can't write them adding the thing inside the square root. Square root ඇතුළේ add තියෙන දෙන්නව add කරලා ලියන්න බෑ. තේරුණාද? So how to write this? Just 2 root. හරි නියම x plus x 2x එන්නේ ආන්නේ වගේ. root 2 plus root 2 2 root 2. Then 3 root 2 minus root 2 2 root 2. Clear? Subtraction also the same way. Then you have root 5 plus 3 root 2 minus 5 root 5 plus root 2. How to simplify this? Make another go. Make it x, y, then when you have x and y, we are adding only the like terms. No, right? We are adding only the like terms. X like and separately we are writing. Same as that. Root 5s we have to add with root 5s. Root 2s we have to add with root 2s. Clear? That's good. 3 root 5 minus 5 root 5 minus 4 root 5. 3 root 2 plus root 2 plus 4 root 2. Like this. That's your final answer. Clear? So we can't simplify further. Right? Then, answer multiplications. Yes, when it comes to multiplications, what will happen? If it is a multiplication, then you can multiply the thing inside the root. Root to multiply. Clear? Multiplications and divisions you can do. But additions and subtractions, we can't do like this. Mathematical. Inside the square root in clear? Okay. Multiplications and divisions. See. So again, pause the video. Write down the previous one I erased now. Right. See. Root 2 times root 3. I can write this as root 6. Root 6 root 10 divided by root 5. This one I can divide as whole thing, square root of 10 over 5, and this is equal to root 2. Clear? This 2 into 3, you can write it as a common root, and square root of 2 times 3, 6. We can write like that. Clear? When it comes to multiplication and division, it's okay. Right. Then, so those things you should know. These are O-level stuff. I want to teach you something new now. Okay, something new. Look at this for them. We have a number called 1 over root 2. We have a number called 1 over root 2. How did the matone me number එක දැන් මෙහෙම අපිට මේ denominators irrational numbers විතර තියන්නේ usually. We don't keep the denominators as irrational numbers. එතකොට අපිට පුළුවන් මේ denominator එක rational කරගන්න. Rational number එකක් කරන්න. So we call it rationalizing the denominator. Right? We call it rationalizing the denominator. මෙයාව rational number එකක් කරන්න පුළුවන්. We can make it a rational number. How? Multiplying both denominator and numerator by the same number. Denominator එකයි numerator එකයි දෙකම මෙයාගේ denominator එකකින් මම multiply කරනවා. හරිද? ඒ කියන්නේ දෙන්නම root 2 ගෙන් multiply කරනවා. So 1 into root 2 means what? Root 2. Root 2 times root 2 means what? What is root 2 times root 2? Yes? Okay. I will teach you something here. Maybe root 2 times root 2. Square root of 4. Ne? Answer is 2. Ne? Root 3 times root 3. Square root of 9. This is 3. Sometimes you may already know. Root 2 square root not say like you may think the root cancels with the square. So sometimes students may don't know these things. Clear? These simple things they may not know. So that's why I'm explaining all the stuff. Root 2 times root 2, this is 2. Root 3 times root 3, root 9, that is 3. What do you think about root 4 times root 4? Root 16, and that is 4. Then pattern. Identify the pattern. Root 2 times root 2, 2. Root 3 times root 3, 3. Root 4 times root 4, 4. Root 10 times root 10, 10. Root 100 times root 100, 100. Clear? Right? So, any number, when any square root of a certain value, when you multiply by the square root of the same thing, then square root multiply if you multiply by the same thing, right, then we are getting the value without the root. Clear? Root 2 into root 2, 2. Root 3 into root 3, 3. Root 4 into root 4, 4, like that. Okay, so you can have a note like that if you don't know this fact. So if it is root a times root a, what is the answer? A. If it is root a times root a, the answer is a. Clear? Right. Then, බලන්න පුතේ දැන් මේ 1 times root 2 root 2. root 2 times root 2 2. හරිද? denominator එක අපි මොකද කරන්නේ? We are making it rational number. එයාව rational number එකක් කළා. Clear? Irrational number එකක් නෙති root 2 නෙති it is rational. So I made it rational. This is what we call rationalize in the denominator. එතකොට ඔයාට આવොත් එහෙම 1 over 2 over root 5. 2 over root 5. What you are going to do? Multiply both denominator and numerator by what? Root 5 ගෙන් තමයි multiply කරන්නේ. Okay? So numerator it is 2 root 5. Denominator එක rational වෙනවා. Root 5 into root 5, that is 5. Clear? So you can write down the topic here. Rationalize in the denominators. Rationalize in the denominator. Rationalize in the denominator. And write down these two examples. Okay, now that is when you have a number. Then me number එකක් denominator කියන irrational number එකක් තියෙනකොටනේ. When you have irrational number in the denominator, no, we are doing like this, multiplying by that particular number, right? Now what do you think? Right, how to do this one? 1 over 1 plus root 2. This is what you have in the denominator. Yeah, what can I do now? If I multiply both denominator and numerator by 1 plus root 2, then what it teaches like I had root 2 in the denominator. So I multiplied both denominator and numerator by root 2. Root 2 ගෙන් මම multiply කරේ. හරි මම මෙයාගෙත් 1 plus root 2 ගෙන් multiply කරලා බලන්න මොකද වෙන්නේ කියලා. Let's see. 1 into 1 plus root 2, 1 plus root 2. And now we have 1 plus root 2 into 1 plus root 2, which is equal to 1 plus root 2 squared. 1 plus root 2 squared means 1 plus 2 root 2 plus root 2 squared means 2. Or else, 1 into 1, 1. 1 into root 2, root 2. Root 2 into 1, root 2. Root 2 plus root 2, 2 root 2. Root 2 times root 2, 2. Clear? Right. එතකොට මොකද්ද මේ? ඉතින් අපිට ආයෙ වෙලා තියෙන කෙනාත් බලන්නකො මේ the thing that we got now with is the here also the still irrational. Still irrational. Clear? එතකොට අර number එකක් තිබ්බම පස්සේ යා rational වුණා, but for this one this is not the method. නේද? What do you have to do? Yes. මොකද කරන්න? I will multiply both denominator and numerator by 1 minus root 2. We say that this is the conjugate of the denominator. Conjugate, a new word, conjugate. Right, what do you mean by this? Now, x plus y, the conjugate of x plus y is x minus y. Conjugate of x plus y is x minus y. Conjugate of x minus y is x plus y. Okay, conjugate of x plus y is x minus y. Conjugate of x minus y is x plus y. එතකොට මේ 1 plus root 2 නේ conjugate එක වෙනවද කවුද? 1 minus root 2. I am multiplying both denominator and numerator by 1 minus root 2. What happens to the numerator? 1 times 1 minus root 2, 1 minus root 2. Denominator කවුද? 1 plus root 2, 1 minus root 2. Can you just familiar නැද්ද? මේ a plus b, a minus b. What do you mean by a plus b, a minus b? Difference of two squares. Okay. I think my difference of two squares එල්ල යන plan මේක ආයේ හද හදින්න ඕනේ නැහැ මේ. First term squared minus second term squared. First term squared means 1 minus second term squared means with a root 2 squared, that is 2. Clear? So I'm getting the answer as 1 minus root 2 over minus 1. 1 minus root 2 over minus 1. I am dividing both terms by minus 1. So we will get minus 1 plus root 2 as the answer. Can you say the denominator is rational now? The denominator is rational ලා කියලා පේනවා. හරි. එතකොට 1 over 1 plus root 2 කාගෙන්ද මම multiply කරේ? I multiplied both denominator and numerator by the conjugate of the denominator. Conjugate of the denominator, we say this. හරිද? අද මෙහෙම ලියාගෙන මේ දෙනව කට් කරලා දාන්න එපා. ඒක ලියාගත්ත කැඩන්නේ. හරි, you not doing that. So then multiply, what is it? Difference of two squares. First term squared minus second term squared. That's how it goes. So first term squared means 1, second term squared means 2. If you simplify also, 1 into 1, 1. 1 into minus root 2, 1 into plus root 2 will become 0. Root 2 into root 2, 2. Clear? So simply apply difference of two squares. Clear? Okay, you can write on this one. You can write down, multiply both denominator and numerator by the conjugate. Multiply both denominator and numerator by the conjugate of the denominator. Multiply both denominator and numerator by the conjugate of the denominator. That's how to write. Okay, now the example sum, another one, I will get another one. Right, we will do this 1 over 2 over 2 minus root 3, 2 plus root 3. This one, 2 over 2 plus root 3. How to do? I have to multiply both denominator and numerator by 2 minus root 3. 2 minus root 3. Clear? So what happens to the numerator? 2 into 2, 4. 2 into minus root 3 minus 2 root 3. Denominator? Here we have 2 plus root 3. Here we have 2 minus root 3. So 2 plus root 3, 2 minus root 3. What is it? 4 minus 3. Clear? So 4 minus 3 means 1. So the answer is 4 minus 2 over root 3 over 1. So the denominator is rational. You have in the numerator you have a rational number. No problem. Rationalizing the denominator. Rationalizing the denominator. Clear? Okay, so there is a very nice story related to this irrational numbers, right? You have heard about Pythagoras now. So the early days, right? He had followers. Right, he had followers called Pythagoreans, right, and those people were known as Pythagoreans. Okay, so they believed that everything is very simple, right? The numbers are very simple. They believed that the rational numbers only exist, හරිද? එයාලා හිතුවේ හැම වෙලේම exist වෙන rational numbers විතරයි කියලා. කියන්නේ any number they thought that any number can be represented as fraction. fraction එකක් විදිහට ඕනම number එකක් ලියන්න පුළුවන් කියන එක තමයි what they believe. Right? So there was a Pythagorean called Pythagoras කියන name මම කියන්නේ මේ ඒ කියන්නේ එයාගේ followers ලා එයාගේ follower කෙනෙක් ඉඳියා. There was a follower, one of his followers called Hipparchus. හරිද? ඉඳලා තියෙනවා. ඉතින් මේ that person has found this irrational number thing. Clear? මේ irrational number එක ගැන මේ root 2 කියන එක කෙනාව අපිට fraction එකක් විදිහට ලියන්න බෑ කියන එක එයා හොයාගෙන තියෙනවා. He has found that. Okay? So because of that reason as like ඒක දැන් ඒගොල්ලන් hardly believe that thing නා හොඳටම ඒක believe කරපු දෙයක් නේ sorry Pythagoreans ලා ඉතින් ඒකට විරුද්ධ දෙයක් කිව්වා වගේ වුණානේ එහෙම ඒක නිසා the legends say that the Pythagoreans have thrown Hipparchus to sea, right, because of finding this irrational number thing, right? So that is maybe true, right? Okay, so that was considered as one of the biggest conflicts in mathematics in history of mathematics. Okay, right, so there are more to explore, right? This is just the beginning of your subject. This is just the beginning. There is more to explore, and this is one of the very interesting subjects as well. Right, so let's meet from other lessons too. Right, goodbye all.